Okay, welcome to this video. It's on solving systems of linear equations with graphing, and we'll jump right into it. I just want to kind of give you a why would we ever use this, and here's an example. I've got Fred, who is, well, he's a spender, and Fred has $14 in the bank, but he spends $2 every day. $2 every day. So his bank account's going down by $2 for every day that goes over. So let me go ahead and label this. These are days. And these are dollars over here. So it's going down 2 for every 1 day. All right. And let me put a line on that. Something like that. So he'll be out of money in 7 days. That makes sense. He was spending $2 a day. Started with 14. And let's see. Was that Fred? I think that was Fred. Fred, his equation is y equals, well, it was going down 2 for every day that went by. And he started with $14. I could have also written that as y equals negative 2x plus 14. I kind of wanted you to see that 1 there as part of the slope. All right, and then I've got another individual, and this is Sam. He starts with $2, and he goes up $2 a day. So he's saving $2 a day, up 2 and over 1, up 2 and over 1, up 2 and over 1. And I could put a line on that. And here is Sam, one like this. And his equation is, this is Sam, and his equation is, well, it was positive 2 over 1x plus the $2 he started with, or 2x plus 2. So y equals 2x plus 2. All right, so those are the two equations. And when we have two linear equations, we call it systems of linear equations. They're kind of working together. And the solution to that is the point of intersection. That's going to become a kind of a critical thing we're going to look for. And we always state it in terms of the coordinate. So this one is at 3 on the x and 8 on the y. And so we would write that as a coordinate 3, 8, an xy coordinate. All right, so that's a little bit about how we might use it. Now let's jump into some of the mathematical detail. Solving systems of linear equations, these are for lines. By graphing means to graph, of course, the equations and identify where the lines cross or intersect. The first thing we want to do, well, we've got two equations here, this one and this one. So with systems of equations, we have at least two equations that are working together. We're trying to find the point at which they intercept or cross. And then we've got to ask the first question is it in the slope-intercept form? And I'm talking about this equation. It is on this one, and that means that the slope and the y-intercept are easily identifiable. It's in this form. All right, and what makes that easy about graphing is that the slope, we start with the y-intercept. It's up here at positive 8, and we're going to use that slope. That slope is listed as negative 4 there. I could drop a 1 under it, turn it into a fraction. It helps me find out the up or down, in this case down because it was negative, and the right or left, I'm going to, basically if it's positive, it's going to go right, and if it's negative on the denominator, it would go left. All right, so from this y-intercept, I'm going to go down 4 and right 1, down 4 and right 1, and then I can draw a line. All right. And this other one, I have to ask the same question. Is it in the slope-intercept form? It's not. This is in what they call a standard form, and I want to get it in the slope-intercept form. It makes it easy to graph. So I'm going to get y by itself. So I'm going to add 4x to both sides because I want to get that off of the left side here, and they cross out, they basically offset each other to 0. I'm left with a positive 2y. These cannot be combined. Some people want to say it's 8x, but it's not. It's 4x plus 4. They're not like terms, so you can't combine them. And then I want to get y completely by itself. It was 2 times y, so I'm going to divide by 2. And some people write it this way, but the 2 has to go into both parts on the other side, both terms. So it's 4x over 2 plus 4 over 2. Of course, that can be written, 4 over 2 is, 4 divided by 2 is 2x plus 4 over 2. And so now I have it in that y-intercept form. I'm sorry, the slope-intercept form. So here's my slope. And here's my y-intercept. They're both the same. I start at 2, and it's going up 2 and over 1, up 2 and over 1, up 2 and over 1. I draw that line in, and the solution to a system of linear equations is the point at which they cross. That is at 1, 4, of course the x, y coordinate. All right, let's move on to some sample problems. That's a basic overview of how to do it. All right, so are these two in slope-intercept form? Yes and yes. All right, so it should be pretty easy. I'm going to start with the top one here. -1 is the y-intercept. -4/3. That negative, I'm going to kind of play it into that. It's going down 4 and over 3. If I were to put the negative down with the 3, then I would go up 4 and left 3. Notice those are still in line with each other. Draw my line. And then I'm going to go to the next one. So I'm looking at the +4 is my y-intercept, and it says up 1 over 3 for the slope, or I could go down 1 left 3. If you think about it, down 1 left 3, that's negative divided by negative, which is still a positive. All right, and continuing that, those are my two lines. This is the point I'm interested in. That is -3, +3. -3, +3 is the solution to that systems of linear equations by graphing. All right, here's the next one. They're both in y-intercept form or slope-intercept form, so they're easy to work with. -2. The slope, there's no slope there. There's a 1 in front of it. That's an understood 1. I can turn that into a fraction, so that's up 1 over 1, up 1 over 1, up 1 over 1, and continuing that. All right, and then this one, the y-intercept is +3. It goes up 6, but I'm off my graph a little bit, so I'm kind of estimating there. Or I can think of that as going down 6, but then I need to go left with that, because down 6, left 1, -6 over -1 is the same thing as a +6. So it crosses, so it comes down like this and crosses right there. And that point is -1, -3. That's the coordinate, that's the solution to this systems of linear equations. A lot of people will graph them and they won't say what the solution is. All right, this is a slightly different one. They are both in y-intercept form, so I'm going to graph them really quick. Seem to know what you're doing on that now, so I'm going to go kind of fast. That was down 1 over 2, down 1 or 2, or up 1, left 2. Has a negative slope. This thing is going downhill, reading left to right. The next one is a +3. It's also going down 1 over 2, down 1 over 2. You see what's happening here? Up 1 over 2. This line is what compared to the other line? It's parallel. Okay, they're parallel lines. So where are they going to cross? They're not going to cross. It's a no solution problem. They're never going to cross. So the answer is there's no solution there, or they do not cross. Last example, and then we got some for you to work. These are, well, they're not in y form or slope-intercept form, so I'm going to change it. A little algebra here. I'm going to subtract that x from both sides. I've got y equals -x minus 4. So I'm starting down here at -4, and the slope is -1, so it goes down 1 over 1, or I can go up 1, left 1. All right, and the next one, I'm going to convert that one. 4x minus 3y equals -9. I've got to subtract that 4x from both sides. I'm left with -3y. A lot of people kind of lose that negative there. -4x minus 9. Some people might have written -9 minus 4x. I like it like this because it's moving towards that slope-intercept form. Dividing both sides by -3, which means all the terms on the right. And negative divided by negative is a positive. Again, negative divided by negative is a positive, so now I've got it in the slope-intercept form. It's easy to identify the y-intercept, and we're going to go from there. We're going to go up 4 over 3. I'm off my graph, so I'm also going to go down 4, left 3, and it looks like they cross conveniently on a nice integer location. All right, graphs don't always cross at an integer spot, but these examples I have so far do. All right, so -3, -1, that's the answer in an XY coordinate form for that problem. All right, this is the you try part. You try these, bring your work into your teacher. I don't know if you're working for a retest or just trying to make sure you understand this, but give it a shot on these problems and your teacher has the answers and can check it over with you.